Saturday night, and I'm gonna go approach a new problem I haven't looked at yet. Problem 2400, 2400. Number of ways to reach a position after exactly k steps. I haven't read this problem yet, so who knows if I'll even be able to get to a solution. If you're seeing this video, then likely I did, because it's unlikely that I'd post something if I crashed and burned. So there you go. You know for sure if I've done it, but in this very moment of this time, I'm not sure if I'll be able to do it. So that's an interesting quandary. Okay, so let's get right into this problem. So number of ways to reach a position after exactly k steps. Okay, you're given two positive integers, start position and end position. Initially, you're starting at position start position on an infinite number line. With one step, you can move either one position to the left or one position to the right. Given a positive integer k, return the number of different ways to reach the position end position starting from start position such that you perform exactly k steps. Two ways are considered different if the order of steps made is not exactly the same. Oh. Okay. So this feels very dynamic programming-y. So if you start at start position 0 and you want to get to end, or you start at start position 1, you want to get to end position 2. So you start here. You could go forward and then back. You could go back and then forward in 3 steps. You could go forward, back, and then forward again. Ugh, dude, this problem. Okay, so there's 3 ways that you can do that. So I'm thinking dynamic programming. So the number of ways. I'll call that the number of ways you can get to a destination node, k, equals the number of ways no. Sorry, because when you're doing a dynamic, so this seems like dynamic programming, right? Because there's all these ideas of like, there's steps and you're trying to get somewhere from somewhere else with this many things built in. It seems intuitive to me, at least, that this is a dynamic programming problem. When you do a dynamic programming problem, you need to figure out what your equation is, right? What your I forgot what the term is, but what's the relationship between data so that you can figure out what is catched when you build out your destination. So what's definitely true is the number of ways to get to the end node using k steps, right? So this thing has a node as the first argument and then the number of steps you're using as a second argument. The number of ways to get to an end node using k steps is what? Well, if I have this node, the only option I have I can only go one position to the left or one position to the right, right? So the number of ways to get to this end node is either I went from the left to this node or I went from the right to this node, right? And to use k nodes to get here, right? To use k steps to get to this node. In order to get to this node, this destination node, right? In order to get to this destination node, I would have to use k minus 1 steps to get to this node, or k minus 1 steps to get to this node. Does that make sense? If I had to use k nodes to get here, that means I must have used k minus 1 nodes to get here, or k minus 1 nodes to get here. Okay. What's my base case? I don't know. So that's using this node or this node. So the number of ways to get to an end node using k is the number of ways to get to end node plus 1 with k minus 1 steps, plus the number of ways to get to end node minus 1 with k minus 1 steps, right? The number of ways to get to here with with k steps is the same as the sum of the ways to get to here with k minus 1 steps and here k minus 1 steps. So now I have this recurrence relationship. So I'm thinking there's a solution which is going to take end node minus start node times k time. So that would be my solution. I have no idea if this is optimal. Okay. But that's kind of where I'm thinking I can find a solution that's within this big O space. Okay, so I got to think of a way of, I have this reoccurrence relationship here, but I got to think of a way of how am I going to build that out into the system. Like how far do I have to traverse for things that I need to find? Because how far out do I need to check values? Okay. So if my start position is, let's do another one that's a little more. All right, this is, oh, it's impossible to do it in that many steps. Interesting. Yeah, so it's possible that you can't, there's no way where you can do it in exactly k steps. I didn't even think about that, but yeah, that's true. But let's look at this problem. So start position 1, end position 2, and I have k equals 3. If I was to look at this as ways, so let's make this a ways array. And let's just branch it out to think about how this is going to work. So the way I have it set up is that thing I'm thinking about first is how big does this array have to be? So this could be like the 1 space. Ugh. How far left can I go from the start position? I can go minus k to the left. Right, but that's as far as I can go from this position, right? Because what I'm trying to do is I'm trying to get a mapping of how big is this domain, like, because I'm looking at how many k ways there are to get to some end node. So I need to have information about how many nodes do I have to look at? How many nodes do I need to calculate values for, right? And so how far is it even possible to walk away from this node to the left? And is start position always less than end position? No. Well, okay, we'll work that in later. But okay, so from k, let's look at this again. How far to the left can I go? Well, I can go to the left 1, and then 2, and then 3. And from this node, let's look at each, oh my gosh. And then from here, how far to the right can I go? I can go 1, 2, 3. So that's how far right I can go. So the systems of nodes that I have to look at values for is the min of start node and end node minus k all the way to and up and including the max of start node and end node plus k. Right? So for this example, I have minus k here, right? So here's my start node, here's my end node. I have to go minus k nodes to check and plus k nodes to check. Okay, so that means for this, then I need to have 1, 2, 3, 4, 5, 6, 7, 8 nodes that I look at. And I start at -2. So look at the -2 node, the -1 node, 0. Okay, let's just do it a little bit better. So look at -2, -1, 0, 1, 2, 3, 4, 5. Okay, 3, 4, 5. And then here are my k values. All right, so k for this example is 3. So these are my nodes here. Let's start working in some different colors here. How about that? So I have my nodes in red here. And then my k values for this are 3, right? So how many ways can I get here using 0 steps, using 1 step, using 2 step, using 3 steps? Okay, so this is our dynamic programming catch that we're going to consider. And these are your k steps. So how does this start? Well, we have this system we need to fill. So how do we start filling it? Well, remember we said that the relationship was here. Ways end node. So the ways, just to reiterate, or let's use a different color. The ways to get to some node n node using k steps equals the ways to get to a node plus 1 using k minus 1 steps plus the ways to get to a node minus 1 using k minus 1 steps as well. Well, for this system, we start at 1. So you can definitely get to 1 using 0 steps because that's where you start, right? So that means for node 1 at 0 steps, it equals 1. Now, you can't get anywhere else in 0 steps, right? You can't, like, transport. So using 0 steps, I can't get to any of these places. There's 0 ways to get there. Okay, now then we go here. So how many ways can we get to -2 using 1 steps? Well, there is no -3, and there is no value here for 0, so that's 0. So all of these values become a sum of these previous 2 values in this system. Does that make sense? Because if you look at this as like a system, right, there's nodes -1, 0, and 1, right? And there's going to be paths between both of them. And the way to get to -1 using 1 step, well, if you start here using 1 step, that's 1. So this becomes 1. 1. How many ways can you get to 0 using 1 step? There's no way, right? Because you have to move every step. You have to use the step to move. 1, 0, 0, 0, 0. Right, and you just keep propagating data like this. So this becomes 2, right? And does that make sense? Is there, using 2 steps, is there 2 ways to get to node 0? Using 2 steps? Well, let's think about it. To get to 0, starting from 0 in 2 steps, what would that mean? You could go back to a node, like -1, and then come back. So that's 1 way. Or you could go forward a node and then come back, and that's 2 ways. No, not to a node, but you see what I'm saying. So that makes sense. So this is enough for me to say that this works, okay? So we'll just keep going down this list and propagating data. Now we may actually be able to save space because notice my variant only goes -1, So I only need to keep information about the previous iteration, right? To determine this column's value, I only had to look at this previous column value's data. Right? To determine this column's value, I only had to look at the previous column value's data. And we're going to have to be a little intelligent about how we do that, but if that doesn't make sense, let's not worry about it too much. So let's just go ahead and do this because my whatchamacallit just ran out of juice. All right. So hope you guys are all having a good Saturday. That's what I hate about these problems. I was like, right now I have an idea, but there's some sort of likelihood, right, that this is not optimal. And there's a couple ways you could look at that. You could say, well, maybe there's more learning you need to do, but this is what intuition led me down to. So if this isn't optimal, I'm kind of just screwed. And that's why this Leetcode game is very much so a numbers game, right? You just got to keep going through interviews because your intuition will lead you to a solution, and maybe 50% of the time it's optimal. So that means 50% of the time you're going to get through the next round, right? And we can play the probability game and say, well, how many interviews would I have to do in order to get a job if I'm 50% likely to do the problem correctly? But just don't worry about that. Just do your best, and sometimes your brain will gift you with the right intuition, and other times it won't. I'm hoping that this is right, but I might submit this and look at discussion and there's a faster solution. I don't know. But let's just go ahead and get back to it. So I said that I was gonna do something different, but I'm not, because I'm kind of interested in just finishing this up. Okay, we're back. All right, so again, remember, we're just populating things like this. So 0, this is 1 because of there. Boom, boom, 0, boom, boom, 0. 0. Okay, this is 0. 2 plus 1 is 3. 0, 1, 0, 0. And then at the end, well, we wanted to find how many ways can we get from 1 to 2 using 3 steps. Well, here's node 2. What have I done wrong? Oh, I screwed something up. Because this is saying all right, so what did I do wrong here? Oh, I put... So I'm starting at node 1, not at node 0. So that means that everything got propagated incorrectly. Slightly. So someone probably watching this is like, you idiot. And you're right. So this is my starting node here. Right, this is my start node and this is my end node. So that means that getting to the start node with 0 steps, that's where I start. So everything else is 0. Okay, I'm going to quickly go through this. It's the same situation though, right? I'm propagating values like this. So the value in any node here, right? The value for a node here is the sum of this value and this value, right? And that's true for anything. So here is the sum of this value and this value, okay? Because that represents going to a previous node using k-1 steps plus going to a subsequent node using k-1 steps, or a next node, if you want to call it that. I do apologize sincerely. 0, 1, 0, 2, 0, 1, 0, 0, 0, oh, doesn't really matter though. 1, 0, 3, 0, 3, 0, 1, 0. Okay. And then what does that mean? Well, to use 3 steps to get to the end node, so that's 3 steps end node where these things intersect is the answer 3, right? Which makes sense using the process. So I had to shift everything down 1 because I made a little mistake. Whoa! Notice how I was trouble capturing my hand over here? It's like I'm a ghost. Okay, so now let's go ahead and write the solution because we're good. So with all this in mind, let's create this ways array. No, we said it was going to be what size? Well, everything starts at 0. And it has length k in terms of for each row. Each row has width k, right? These have width k because, well, k is 3. So k is 3 and this has width 4. So k plus 1. I'd always do this in interviews because this kind of stuff can be annoying. We actually don't want to use that much memory. So what we can do is make this instead. Yeah, but then we'd be copying values every single time. We have to calculate values every single time. So we copy values, it doesn't change anything. Okay, it doesn't matter. So ways equals. So instead what we can do here is ignore my wife's messages. You know what I mean? It's like women, you know what I'm saying? It's like I'm trying to Leetcode over here. Like I'm trying to be elite. I don't want to feed the dog. I'd feed my dog data structures, bro. What are you talking about? So since the information for one column is only based on the previous column, you don't need to keep all of this information. Dude, you don't need to keep all this previous information. You only need to keep information about the previous iteration of the algorithm, right? Like the fact that I'm calculating this last column here has nothing to do with anything here. All of this is irrelevant now. The only important column left is this one. Okay? So what that means is we don't need to keep all the extra information, so we can cut down on our space-time complexity a bunch that way. So we can just keep ways as just the size of the column. So what was the size of the column that we agreed to? Well, we said we needed indices from the min of Sn En minus k to the max. And the problem is all of this is going to get... So what I'm going to do is I'm going to shift over everything to 0. Right, because if I start at 1 and go to 2, that's the same as going from 0 to 1. Because this is causing a big headache. I'd rather shift it from 0 to 2 so that it's easier to figure out where things need to go. And then I'll add k. Should I just make it a default dict? I'm thinking about just making it a default dict. Let's just make it a default dict so we don't have to think about all these shifts and bit shifts. The fact that we're not starting at 0 and then we have to go minus k and all this joke. So we'll just make it a default dict where the value is 0. And then we'll go from 0 to k, or from 1 to k. So for, what do we want to call it? I guess, step I. We'll call it step. For step in range 1 to k plus 1, because we want to include step k. Then we'll say, well, first thing we do is we say ways at the starting position equals 1 at 0. Okay, so this is not, the ways at starting position equals 1, right? Because when we're at the 0 step, we can always go to the starting position, right? So we go from 1 to k minus 1. We say we'll create a new array. So for each step, we'll create a new ways. Zero. Let's say, so we have to go for each node in the range, the min of start position, end position. Right, this is directly from how many nodes I said we had to look at. Start position, end position, minus k to the max of start position, end position, plus k plus 1 to include start position plus end position plus k. So we'll look at this range. Yeah, that gives us k squared, and I know that it's not, whatever. That's fine, I don't care. So we'll look at this range, and then we'll say, okay, well, new ways, and this is just the equation now. The new ways to get to this node equals the ways to get to the node minus 1 plus the ways to get to the node plus 1. And then after you're done with this, you just set ways to new ways. And then when this whole equation is done, you return ways at end position. All right, now I think this might be too slow because I'm adding an additional k to my solution. So it's k squared, right? Maybe if k is small, it's okay. This is probably much too slow, which I'm worried about. Wrong answer. Wrong answer because somewhere in here it said I need to modulo something by something. Okay. 10 to the 9 plus 7. I always forget to do that. Don't forget to do that in a competition. You can forget to do that in an interview, probably, unless they don't like you. But I don't think someone's going to dock you down points for forgetting something simple or silly. What they may dock you for is if your solution is time limit exceeded. All right, that's good enough for me, dog. So let's look at... so someone in here probably has a better runtime. K log K. Okay, so it looks like there's a yeah. So it looks like there's a mathematical way of doing this. Mathematical? Like a non-dynamic programming way. But I'm not going to, I mean, who knows? It just depends. But, yeah, so this was my solution here, right? Because you have the position to the end position plus k times k. So it's not as fast as this mathematics one, which I'll have to look at. But just for the sake of a dynamic programming problem, I think this is pretty good, right? In terms of space, okay, so what is the runtime complexity, since I keep talking about it? So for time, we have to look at each step, right, in the range k, so that seems pretty easy. And then here we look from the min of starting position to the max of starting position, plus k on one side, minus k on another side, so that's, we had to do 2k inside plus end position minus start position, whatever that is. But we could just call that start position, it's fine. And there you go. And then what about space? Well, you notice that we keep updating ways, so we don't keep more information than this number of nodes, start position, end position. So then we just have big O of end position minus start position. I mean, this is kind of weird runtime. Start position plus K space. All right, guys, so that's me the first time trying this problem. I'm going to be interested in looking at the mathematical solution, which is almost linear with K. K log K is definitely faster than K squared plus something else times k. All right, guys, have a good one. Bye.